Recording again. Okay, so in this section, we are going to discuss, I'll say, the basic concept in R. So here we're going to start with the introduction to R and also the RStudio. So again, I will skip the section. We don't need to, again, download, install the R and RStudio. We have already done that. So let's look at our objective here. So hopefully, when we finish this lecture, we should be able to write a very simple code in R. Again, this course we are going to use only R. So we got okay. So also about the final projects, as I said earlier, we're going to use only R. Sometimes we have students using Python, and I'll say no, you cannot use the Python. The reason why, because our university have two courses. CS 628 is data science using Python. So they use fully Python on data science. And this course is R, statistics using R. So if you come and use Python here, it's like you are taking the CS 628 twice. So that's why this course we focus 100% on only R. So again, our main objective here, we're going to write a very simple R coding that will create and also modify variables. So here we're going to discuss about variables. And also we are going to use the environment pane. We saw the environment pane in RStudio that we can view variables in memory. I use the term objects, sometimes object variable. So a variable in terms of computer science will be the place we can store data, we can save data. Good news in programming today, when I declare a variable or when I name a variable and I want to use it, we don't care where it's saved. The computer and the operating system does all the work for us. So operating system randomly we locate a memory location, then save the data for us. Everything will be done by operating system. Yeah, so variables in mathematics means a value. Variables in computer science means a memory location. And actually, we shouldn't get confused. I say, man, I have a little bit bias here because in programming language, we have like maybe 4 different paradigms or 4 different categories. For example, imperative programming language is the one that is common among programs, like, for example, Java, Python, maybe R, etc. So in imperative language, a variable means a memory location. That's why we can use a loop. I can update a value. Let's say sum equal to sum plus I. So you can see I have a value in I have a value in sum. When I add the two together, I put the answer in the same location of sum. I can do that in an imperative language, such as R, Python, C++. But we also have a programming language called functional programming language. The functional programming language example would be the scheme language or F#, ML. These languages consider variable like college algebra. So there, the variable is a value. There's nothing like assignment operator. Assignment operator means equal. So if you want to do something over and over, let's say in a scheme language, you have to write a recursive function. But in Python or R, if I want to do something over and over, I can use a loop. Yeah, so that's what I want to explain here. But here we are zooming again. This is imperative R. Variable is a memory location. Then we're also going to learn, I think this is one of the main reasons why we write a lot of programming languages. Do some arithmetic operations and logic decisions. Then we're going to intentionally make some mistakes. Then we're going to interpret the error. So in programming language, we have 2 types of error. I would say 3, but major is 2. We have the syntax error and semantic error. Syntax would be the grammatical error. So R said we should use assignment operator to assign a value to a variable. If I use let's say addition operator to assign a value, that would be a syntax error. Semantic will be the meaning. I want to write a function to find the square of 2 values, but I write a function to find the sum of 2. I do different operation altogether. So the result will be, and the answer will not be what I was expecting. So that's a semantic error. Then we have the runtime error. Runtime error means maybe I divide the value by 0. The program will crash. Unless we have the exception handler to handle the exceptions. Exceptions will be an error that takes place while the program is executing, etc. So yeah, so that's what we mean by here. So hopefully, so that's our main objective. Hopefully, when we finish, we can describe the overall purpose of our data analysis. We'll go through that also. We have 5 phases of data analysis. This will be a generic, I would say, framework or something. It depends. Some textbook may have 7 phases, 3 phases, so it depends. Also, we're going to describe the main uses for RStudio, source, console, and environment base, which we said earlier, and also describe the 4 basic types in R. When we say basic type, the data types. For example, if we have a whole number, which could be integer, we have a decimal number, or we have a Boolean value. A Boolean value will be either true or false, etc. We discuss. Okay, so if no question, let's move on forward. So first, we have something here, which is a graph, or I would say a data visualization. So this diagram would summarize, I would say, the component of data analysis. So I would say that one of the key points, one of the key points is that data analysis always include data visualization. And of course, data modeling also, or predictive analysis, etc. So here, for example, let's see what data we are using. Based on the graph, I can say that, okay, it's kind of like 1918 Spanish flu. So that's our legend here. And we can see when we visualize the data, we can easily see the pattern on the data. Yeah, I think that's the main goal here. And also data visualization is a very great tool because if we have this data let's say in a tabular form, in a text form, so hardly before we can see this pattern. This pattern is telling us, the different colors is telling us the age, if we look, age group. And we can see which age have a very high death rate. This is the death per 100K, etc. So the goal here again is we just want to express the importance, or what term visualization, data visualization is a very, very important tool in data analysis process. So here we say data visualization often provide the best insight into the data. Yeah. So next we will talk about what data analysis include. And also let's just go through the related terms here, if we need to define them or we need to explain. I think everything about analysis is based on data. Data may come from different sources and different formats, different form, etc. So that's what. And I would say that when we have AI here, I would say the AI is the mother of everything we are studying here. So artificial intelligence, machine learning is part of it. And actually deep learning is part of machine learning. So the concept of deep learning starts with a convolutional network. As a network, convolutional here. Neural network, let me say neural network. So a neural network with maybe only one hidden layer, maybe normal neural network, we have different algorithm for each one. Then a deep learning, most textbooks will tell us that if we have a neural network system with over 5 hidden layers, then we call it deep learning. Data mining, I would say machine learning use data mining. Data mining fall mostly in 2 categories, I would say, supervised and unsupervised. Supervised can be classification, regression, unsupervised clustering. But machine learning also have the reinforcement learning. So machine learning can be 3 major, or even 4 major. We have supervised, semi-supervised, unsupervised, then reinforcement learning. In data mining, we do not use reinforcement learning much. Even including data science, we don't use much reinforcement learning here. So data science and data mining kind of close to each other. But when it comes to big data analytics, I talk about MapReduce, Hadoop, etc. And that would be the major difference between data science and data mining. Sports analytics, business analytics, data analysis, I think they are all related. Sports analytics means we are using sports data. Business analytics means most likely we are using, business data. So in short, I can also say that the data science is a field that also covers what? Data analysis, but also include advanced skills. The advanced skills actually, I can even mention data mining, but mostly machine learning and deep learning, as we said earlier, can be part of data science. So, let's see. And also, that's the main term here, data analytics, again, visualization, modeling, we talk about that. As an example, modeling normally will be supervised learning. We do a lot of modeling. For example, I can have any type of data from any field of studies, sports, business, medicine, etc. If I have a training data, which means I know the label, the target variable, I will use that training data to build a model. Then I will use the test data, which means I don't know the target variable, the result. And if the modeler can give me a good accuracy, let's say at least 70% up, then I have my model now. Yeah, so again, we may talk about that, but as I said earlier, our textbook, our syllabus doesn't go detail about this concept, but previously on the students' previous projects, they focus a majority to some form of, again, data analysis project always. Okay, so if no question, let's move on to the next slide. So here we'll say, what do you need to do before you start analysis? Well, I think the first thing, of course, we have to have a goal. So the first thing we are saying here is that we should set our goal. So here, the goals of analysis should be specific. Yeah, you have to be specific. Example here, like trying to confirm or reject a particular hypothesis, or trying to answer a particular question. Also, the goals of analysis can also be general, like trying to summarize the main characteristics of a data in order to form a new hypothesis. So in some many studies, especially in statistics also, I have a question, some studies to do. First, maybe I can start with the descriptive statistics concept. And from there, I can be able to formulate my hypothesis. Then I may apply whatever hypothesis inferential statistics concept to move forward. Yeah. So the goals of analysis can also be general. Yeah. Trying to summarize the main characteristics of a data in order to form a new hypothesis that can lead to that can lead to a further analysis also. Also, I think next step, we need to define our target audience. Example can be managers, clients, etc. Then after that, we need to get our data now, do our data preparation, because we set our goal, we know our audience. I think that would be the next. Yeah, so we get the data. Where do we find the data? Are we using a primary data or secondary data? So a primary data will be a data that we generated ourselves, and the secondary data will be a data that has been used before. Most of the time, that's the data we are going to use in this course. For example, data can come from CDC, NIH, that's National Institute. Also, what the Cargo. Cargo is very common. Cargo is a website mostly for data science, also a lot of information there. So it can come from many sources. Then that will be, again, a secondary data. So the next step will be, we load again here we are assuming we are using R. So we load our data into a data frame. Then we start our cleaning process. Here we'll be preparing the data. So the cleaning can include discretization, normalization, etc., etc. Even handling a missing value or invalid. For example, there's a age group, age field, and we have one record saying that a patient age is 2,000 years. I mean, that's impossible. Most likely to be 220, even 200 is impossible. Maybe 20. Missing values sometimes we can say, okay, if the missing values is less than 10%, we can ignore it. If it's more than 10% of the whole data set, if it's a quantitative data like age, we can find the mean of all the patients, and the mean value we use it. Or media is up to the company or the data analysis principles. Now, if it's qualitative or nominal, maybe we can find the mode. If majority is false, then we keep false. Majority is true, we keep true, etc. So there's so many ways we can do, again, data preparation, many techniques. Sometimes even if the values are too big, let's say we have 100 and then 10 million. Wow, 10 million with 100, the effect will be very small or even none. So we can normalize this data by taking even log base 10. So I know log base 10 of 100 is 2. Log base 10 of 10 million will give me 7 zeros. Yeah, 7. So we can see 2 and 7, they are closer than 110 million. So this will be a process of, again, normalizing the data, the values. So that's the cleaning the data. Then we prepare the data. Prepare data we can do, for example, here add a new any column you need, or remove any column you think is irrelevant. Now in advanced stuff in machine learning or data mining data, we can use something like principal component analysis or singular value decompositions to do all this dimension reduction, reduce the attribute, etc. So the next, we are ready now. Our data is ready. So we apply whatever algorithm we have, whether it's supervised learning, support vector machine, neural networking, etc., or if it's clustering, which one density, k-means, etc. You again apply your algorithm on your data. Now, if we're doing clustering, normalization is not really important. I mean, it's important, but in supervised learning, you are building a model. You're using the training data to build a model. So if the data is not good, the model you get will not be good. But if I'm doing unsupervised, let's say clustering, the concept of clustering is that you are going to divide the data into some clusters. Let's say if it's 2, 3, whatever. For example, if you are doing the k-means, k will be the number of clusters you need. So if I need 4 clusters, yeah. Now, if 2 data points are similar based on distance measurement, etc., mostly we use distance measurement. Then those 2 data will be together in one cluster. If they are dissimilar based on the distance measurement, then they will be in different clusters. Most of the time, outline can have effect on a clustering, but data preparation, we don't do much in that. Yeah. So let's keep going. So after we finish that, then we have the algorithm, we run it, we get the result, then we present our data. So now, before we can start any analysis, in general, we need to consider a good practice again, that we can set our goals and also define our target audience also. And then we can also divide the typical analysis, as we said in these slides. This is step 5. We can divide it into 5 phases, like what we just went through right now. In practice, as we said, it can be more or less. Okay, this is just generic form. And sometimes one phase can overlap the other. It depends. Yeah, so let's wait for a few seconds. That's all we will say about data analysis, not much here. Here we're going to focus more on the R. So we saw the RStudio and we were asking if any question. there was no question, but as we said earlier, R is an IDE, which is integrated development environment, which means it has everything. When I say everything, I mean it has to run it, to use the interactive, the output area, to see the object you are using, the historical concept, everything is on the right upper side. Lower right side will be the output result. And then left upper will be where we write our source code. And then interactive console mode, we get it on the lower left side. Yeah. As we say, if you want to run, we click on the run button here. Or we can go to, for example, here also we have some, and then again, we'll go through some of these menus as time permit, if time permit. The build, debugging, same as any programming language debugging, if we have any error. So as we can see on the board, as we can see on the screen here, the RStudio is divided into 4 windows. And as we said, each window will be called a pane. So one more time, the top left pane is the source pane. This is where we write our source file. We can use it to open, view, edit source code, and data files. So when you open RStudio for the first time, if it doesn't display this pane, you can always, again, but most of the time it will display. If not, we can, again, display it. So we can display it by doing what? Open the source file, or by creating a new source file, like what I did. Click on File, click New, then the source file, then this section. If it's not open, it will be open. Or right now, let's say I have a program already. I want to create a source file program to run. I want to create a new one. I can either save this and close it and go back to File, New, or just go back to File, open it. Then as we said, the bottom left pane is the console pane. We can use this pane again to run the code, to view the output of the code that you run, etc. Then the top right, as we said, the environment pane, which again, here we can see almost all the variables we have, etc. We can view the data and also variable data currently loaded into the like average. The value there right now is 17.834. We have a variable name count. The value there is 10. We can see from the source code we assign 10 to count. Average result we get here also is what is here. It's 17.834 because it's 178.34 divided by 10. That gives us the average, etc. So I think that's enough for the RStudio. Let's wait for a few seconds. Now we will go through some few coding and we'll do as much as we can till 5:40, if no question. Okay, let's continue there. So let's see the first one. So here we say we have 2 R statements. What I'm doing here, I'm assigning the hello string to a variable name message. This is, I'm using the console here. So if I type message and press enter, it will give me the result in the content of it. But let's say assume here, let's start with beginning. We assign message. Oh, let's see. This is the first code we saw now. So let's run it and see what happens. So I'm going to copy it. Again, I can use it in the R console or the studio. This is very short one. Let's just go to the tap it here. Paste it here. Let's see if it goes. Yeah, go there. So we can see hello, we assign. Then if I type message, again, it should give us hello world, the content of the message. So that's all for now. So now here we also have for example, in any programming language, always comment is very important. When you have a comment, the comment will explain what your code is doing. Good news with comment is that the compiler, or in this case, our R or RStudio, when we run it, it will ignore the comment. So in R, in order to write a comment, you have to start with the pound sign here. So if you start with this sign here, everything that comes after that sign, the pound sign, will be ignored by the compiler. It's not going to be, or the RStudio execute running it, it will not run it, or the console also. So here we have a comment. The comment also is very good, as we said. It explains the code. For example, here we say the code that comes here normally we store a string of characters in a variable name message, which is right. Well, a string of characters here we have is hello word, and we store it in a variable name message. The next one we say display the variable name message. So display message. And normally if we type message like that, we saw the example, press enter, is going to give us the content of it. Yeah, so this is what we just did now. We have the message, type message, press enter, it give you the content of it. So here again, we are using the console, the lower left side. And we said if it's a studio, RStudio. So we say to run a statement in the console pane, just tap it after the right arrow prompt, and then press enter, that's it. If you run a statement that displays output, the console pane begins each line of output with a number, as I think we saw it, the square bracket and 1. And actually, that's example here again. And start the first line. If there's a second line, it will be square bracket 2, and so on, 3, 4. Next, to display previous statement in the console pane, just press the up and also down arrow Y in the pane. So you move up and down. Then, you can rerun the statement that currently displayed by pressing enter. Let's wait for a few seconds. If no question, let's keep going. So this is the source again, and a console pane. As I said earlier, if you think we should run it, we can type it, but if we look at this section, you can see that we are trying to perform some calculation here and display the result. We have a total value of something, and items that we have 10 of them. So we store the total to a variable named total, just type in it straight, and we store 10 into count. To find average, now we know the content of count is 10. The content of 178.34, the content of total is 178.34. So normally we know in programming language, instead of writing 178.34 divided by 10, we can use the variable name. So the advantage that is here is that anytime the total value or the count change, automatically the average value will change also. And that's the same thing on the consoles down here, the same thing we are doing. Now let me take a short. Yeah, also, so if this is okay, then let's go a little bit. Again, maybe I may try to go not really fast, but just again, this kind of introduction. If you have a question, as I said earlier, you can again raise your hand or start to speak. I'll keep quiet, listen to you. So I think I'll skip all this section. We already said everything here. This is for those of us who are new to it. We said to open a new file, especially in the script. You click on file. Here we are going to open an existing, so you click on file, open. But if it's new, we click on file, new file, then R, which I think we did in the previous beginning. Actually, I opened this new. So you go to file, new file, then script, then you can start to, again, write your code. So next, again, we explain everything. So I'm just wait for a few seconds. We are going to focus on, I'm focused on I use only Windows. So every time I'll be doing, if it's a hands-on, my computerized Windows, so always I'll focus on Windows. Okay, so if no question about this, let's keep going. So we also talk about the environment pane. Here we're going to focus on only the first two. Environment will give us all the variables we have and their content. Then the history section will tell us everything we did previously. So for example, here I use the studio some time ago. So when I click on the history, you will see what I did in previous sections. And the environment will tell me the variables we have. I think it should be this file, one of them. This file. Should be one of this file. So again, the environment will give me all the variables with their content. And this will be historical, all the things that I've gone through. Now, the next is how to view variables. Okay, so we did that already. So this is the hands-on step-by-step, how to view the variables in environment pane. So as we said earlier, R stores its variables in a computer main memory. We don't have to worry about that. Operating system take care of that for us, which will be temporary. So environment pane show all of the variables that are currently stored in main memory. So you click on the variable, you see the variable names and their content, which we went through the steps. Wait for a few seconds if any question here. Let's keep going there if no question. So these are the 4 basic data types in R. First will be a now. This is the trick here. For example, in Java or some major programming language, a character means only one single character, digit, or symbol, but it must be in one quotation, single quotation. But R is more flexible here. When we say a character type, it's also a string. So we can have only one X, it have to be in double quotation. In Java, we'll call this a string also, but it can't be a character. It's different to be only one single quote. So these are all strings. String can be anything, digits, symbols, as far as it's in a double quotation, it's a string. Integer normally is a whole numbers. Then double will be decimal values. Then logical type, which is Boolean, will be true or false. So that's the type names, type and the names. So in our coding, we may have double or logical, but the name is Boolean. Then take only 2 items that are true. Okay, false. So let's wait for a few seconds if any question. Okay, let's move on then. So you have some few examples here. Let's, as we said earlier again, a variable always store data. This data can be changed. That's why it's called variable. It can be changed or vary as the code executes. So again, for example, how to create an initialized variable name. We have the name given to us. No, the name we had chose our name. Yeah. So here, for example, I have the variable name is title. And to assign, this means based on the type of data that we assign to the variable, will determine the variable data type. So like in some programming like C, C++, Java, if this is a string, I have to declare it as a string. The data type name comes first before the variable name, the assignment operator, then we assign. But here, again, this is how we do it. Kind of close to Python also. In Python, we don't have to show the data type, the correct. Because the type binding normally will happen. We will call this dynamic binding. The type and the name happen during the running time. And like in Python here. In Java, it happened before running time. So the type checking take place during the compiling before running, which is good because one of the disadvantages about dynamic binding, during the running time, more resources it takes time, more resources will be spent on doing all this. Yeah, so it depends. So we have all these four. We can see that based on the content of each of these four variables, we have their type based on the content. The last one is Boolean type, logical. Let's wait for a few seconds if it's okay. Okay, so if no question, let's say the next, this is by convention. Yeah, we have different types, snake case, camel case. Camel case is used a lot. Camel case means here, for example, I have three words. The first word, we start with the lowercase. Then the second word coming, we start with the uppercase, no space. We join all together, third word, etc. Yeah. So this is common, which we call the camel case. This is by convention, common convention, which means you know there's no error. You can select any case you want. The only thing, there will be a rule saying that, okay, a variable name, there's no space. So if you put a space between, then it's an error. A variable name cannot start with a digit. If you start with a digit, then you have another error, etc. So if you follow the rules, and also no symbol except underscore, period, etc. Yeah. So let's wait for a few seconds. If no question, let's move on. Now we have how to view the value of a variable. I think we did that already. Previously, we have a message. We assign hello to message. Then when we type the message second time and press enter, it gives us the content of message. So the same thing, we have a title already assigned age group. If I want to know the content of title, I'll just type title. Here I'm using the console mode. So if I type days per week, press enter to give me the content. If I type here, we already have that we assigned the values already. Title is age group, days per week is 7L, 4.5 for rate, true for is Monday. So if I type is Monday and press enter to give me true. Okay, so if no question, the next section is how to view the type of a variable. A type will be the data type, whether it's a string, integer, double. We have a special function called type of. So this is a built-in function in R. If you use type of, the parameter or the argument of the function will be the name of the variable that you want to look the data type of it. So here, if we type of title, by title, the content of title was a string. So the data type is character. Remember, days per week was, I think, 7L or 1L or so. So that's the whole number. So if we say type of days per week, and the argument again is the variable name, it should give us integer. Same thing with rate and is Monday. This Monday was true, false. So it's logical. The content was true. So if no question, let's keep going. How to change the value of a variable? Well, just assign a new value then. So for example, here we have rate 1 is 4.5. We check it is 4.5. Next time I'll assign 5.3. So 5.3 we override as a ride or rating. We're going to delete the 4.5 and the new value will be 5.3. The last value will be assigned to a variable will be the current value. So next time we assign 6.8. to rate 2. Now we say rate 2 assigned to rate 1. Yeah, it's possible. The content of 6.8, we are giving it to rate 1. So now rate 1 new value, instead of 5.3, it will be 6.8. Now, R is a case sensitive. So here we say code that causes an error due to incorrect case. So you can see the name of the variable is rate with the lowercase r. Let's say rate 1. So if I change the cases, any of the 4 cases here to uppercase, we get error because that object doesn't exist. That's why we are saying object rate 1 not found. Object is the same as variable. So this means the names of a variables in R is, or R in general, is a case sensitive program. There are some programs that are not case sensitive. And we also saw how to change the data type for a variable. So now we check is double. So to change it, I sign. So previously it was, let's say it was 5.3. No, it was 6.8. Yeah, last value was 6.8. So it's double, 6.8 decimal. Now we decided to assign 10L to rate 1 again. So this time, rate 1 value will be a whole number. So if we check the type of for rate 1, it will be integer now, which will be 10 again. In some programming language, you cannot do this. Most programming language. So especially the programming language that we check the type before running, like Java, C++. If the type is int, and you try to put a decimal value in it to give you error, because you already said it's int, so it will be int throughout. Other than that, the next section we have arithmetic operators that we can use in R. So we have addition, subtraction, multiplication, division, the same thing. Same like Python also. Sometimes we may have integer division means, for example, if I divide 10 by 3, the answer should be 3.33 something. But if you say integer division, it will give you only 3. So it will give you a whole number. Integer, as we said earlier, is a whole number. If you want it to give you the division value, then you use the first division here. Or we use this is for, again, integer division. You have the percent sign, division, another percent sign. Modular operator is used a lot in computer programming languages. In real world mathematics, so we don't use it all. So modular means, for example, if you divide 2 values, the remainder will be the answer. So 3 divided by 2 is 1, remainder 1. So if I say 3 modulus 1 or modular or remainder, and that will give me 1 because 3 divided by 2 is 1, etc. Then we also have exponential. Exponential, we have 2 types, so it's up to us. We can use the caret or the double asterisk will give you. So we're going to see, we have only 7 minutes, but again, let's go as much as we can. We're going to see some few examples on arithmetic operations. If you think we should write the code, we can run it. Actually, we did it already. We did a couple of them. So this example of 5 plus 3 is 8. 5 minus 3, 2. 5 times 3, 15. You can see here we are doing division, regular division. So when we say 5 divided by 3, it also gives us the decimal places. But when we do the integer division, 0.6667, they're gone. They give you only a whole number. So 5 integer division by 3, it will give you 1. And then modulus operator. If I divide 5 by 3, the answer is 1, remainder 2. So 5 modulus 3 will give me 2. 5 to the power 3 is 5 times 3 times 3. Caret means power, or exponential. So it's 125. If you like, also, you can use the 2 asterisks here. So we still got a few minutes. Let's keep going. So this is another example. We can have same like college algebra. We can have arithmetic expression with any amount of operators, arithmetic operators. So for example, 3 plus 4 times 5, it works the same as college algebra. The order of precedence, multiplication comes before addition. So 4 times 5 is 20 plus 3 is 23. We can use a parenthesis to change the order of precedency, same as algebra. So 3 plus 4 in the parenthesis means parenthesis execution first. But that's what we call the PEMDAS. Parenthesis first, exponent, multiplication, division, addition, subtraction. Same as college algebra principles. So this will give us 3 plus 4, which is 12. 12 times, 3 plus 4 is 12. 3 plus 4 is 7. 7 times 5 is 35. Okay, so let's keep going. It's no question. So the next section, assignment statement with arithmetic expression. So let's see here, we assign a special value for rate. Then we say rate times 100,000. So it will be 0.0198 times 100,000. And that will give us 1980. Here we are trying to say that we can write arithmetic expression also using a variable name. If there's a content in the variable or the variable exists. If the variable does not exist, then we get error. Calculate hours and remaining minutes. So here we assign 127 to minutes. And we'll say we want to know how many hours there. So it will be minutes divided by 60. And you have to be integer and division because we want to get a specific. So this will give us 2 hours, which is 120. Remainder 7. So if I want to get a remainder, then the next, I will say minutes modulus 60. And that will give me the remaining minutes, which is 7. So 127 minutes is 2 hours, 7 minutes. Another calculation we make here is to find the parameter of a rectangle. A rectangle always have a width and a length. And to find, we have 2 widths, 2 width and 2 length. So if you have, we can write the formula width plus length plus length. And we decided to double it. So width plus width is the same as 2 times width. Length plus length is the same as 2 times length. We know the width is 4.25, the length is 8.5. So we can, this formula will work. And if we run it, it will give us the parameter to be 25.5. So first we enter the width, we enter our length, and to find the parameter is 2 times the width plus 2 times the length. And that will give us. Next, they say we should calculate the decade for a year. So we use 1992 year. So we assign 1992 to year. So the decade will be year. This time you have to be again integer division. We don't need a decimal. And then it's decade, so times 10. So if we do this expression, we get 1990. Wait for a few seconds. So we have only 4 slides going, so let's try and finish it. And we know finish chapter, the unit 1. So next also, there are some, as we said earlier, there are many built-in functions for R. We will see some of them in the future. One, also we have a constant values. So in R, PI is a constant value, which is 3.14159. So we can use PI to calculate the area of a circle. The area of a circle will give us pi times R square. So we get the R value from the user, which is 10. We install it to the radius. To find the area, we write the formula pi times R square, which will be radius to the power 2. So when we run this, our answer will be 314.1593. Pi is 3.1459. And then we have 10 square will give us 100. So that gives us 2 more decimal places. So 314.159. Now, if we want to see the content of any of the variable, as we did previous examples, we just type the variable name, press enter, and it will give us the content. We can also use arithmetic on logical views. So for example, here we say false plus true plus false plus true plus false. Then when we click true count, it will give us 2. We have 3 falses, but we have 2 truths. Yeah. And we'll have one more slide. So here, the 2 common error message in R, we saw that already because of case sensitive. You are using a variable for the first time for something, but you didn't declare it or you didn't even assign no value to it, so it doesn't exist. So example here, we have a length 8.5, width 4.24. Area, we say it's length times the width. Here we say error in length times width. We have what? Non-numeric argument to binary operator. Again, non-numeric. Hopefully we understand numeric means value. So to a binary, again, operator. So let's wait for a few seconds if this section is okay. Or if any question from today's lecture. So that will be our conclusion. We have 5:41. So let's see if any question which will go here. Okay, so if no question again, I'm going to stop the recording.